Okay, this is the alpha. This is a beta. There's a wall. I think it'll be much easier for you. There's a wall, elastic wall. We have to find out the time period of pendulum for alpha greater than beta, for alpha less than beta. Find the time period of oscillations of pendulum for first case alpha greater than beta or beta less than alpha, beta greater than alpha. And if alpha greater than beta, what does it mean? Suppose alpha 30 degrees, beta 10 degrees. I think it will not go and collide with the wall, no? General, directly take help of the basic diagram. If alpha, so the pendulum will be oscillating so here you can check it. This is alpha, this is beta, this will be beta. So no question of the bob going and colliding with the wall. So what is the time period of pendulum? In this case, it will be 2 pi under root of L by G. So what is the basic idea? The bob will not collide with the wall. So no question of like a time period of oscillation will be 2 pi under root of L by G. This is the first case. Second case will go for it. If alpha less than beta, I'll make it this. We'll try to wind up everything here. Second case, alpha less than beta. What is alpha less than beta? How things will be? Alpha less than beta. In fact, here you can see this. So like we are not understanding that beta. Can you show us beta? So here the bob, I will, of course the bob will not go there, but if it can oscillate, it can, would, if there were no wall, no, it could have gone to till here. This is the meaning of that beta. So I think the wall will not permit for the bob to go on the other side. So it'll go, come, will collide and will rebound, no? So here the bob like this, we should take it out. So it will come and collide. So just I'll show that angle that will be sufficient. The beta is greater than alpha is what that angle is what I'll try to show it. Now we'll take the positions 1, this is 2, this is 3. Time taken to move from 1 to 2 will be the 1/4 of time period of oscillation. So what is the time taken to move from 1 to 2? Should be 1/4 of this one. How to calculate time taken for the bob to move from 2 to 3? Yeah. This time is what needed. Time taken to move from 1 to 2 is will be 1/4 of the time period. 1/4 of T1. Time taken to move from 2 to 3 has to be calculated. What is the maximum, what is the amplitude of oscillation of this bob? Will be beta, no? So then we'll take this equation, theta equal to beta sine omega t. Time taken for the angular displacement to become alpha. Is it okay? Then what is omega? Omega should be equal to G by L. Time taken for the angular displacement to become alpha is equal to beta. Agreed. So this is a time taken to move from 2 to 3. So alpha by beta sine inverse of overall what is the time taken? Time taken for the oscillation should be equal to T dash should be equal to 2 times of T12 plus 2 times of T23. This should be equal to 2 T1 by 4 plus 2 T23. T23 is root of L by G. T1 is what? 2 pi. So this will become pi root of L by G plus 2 root of L by G. This is time period of oscillation for second case. Just simple mathematics. Okay, fine, sir. We didn't understood this. What actually this is like. Time taken for the angular displacement to become from, because this is the mean portion we'll measure. Beta will become amplitude of oscillation. You can see this one. This alpha is. What is the time taken by the pendulum for its amplitude to become from 0 to alpha? The angular displacement to become alpha. Here the bob is having 0 angular displacement. Now as it ascends, angular displacement will become alpha. So what is the time taken for it? Okay, this we will take the next condition.